How are jet contrails formed? Condensation explained. Imagine flying through the sky and suddenly seeing long white streaks behind the airplane. Those streaks are called contrails, and they tell us a lot about how gases and phase changes work in the atmosphere. When an aircraft flies high in the sky, its engines produce hot, humid exhaust gases. These gases contain water vapor created during fuel combustion. As the plane moves into colder, low-pressure air at high altitudes, something interesting happens. The hot exhaust gases mix with the cold air, causing the water vapor to cool down rapidly. When the temperature drops below a certain point, the water vapor condenses into tiny liquid droplets. These droplets are so small that they are invisible to the naked. But if the humidity is high enough, these droplets quickly freeze into ice crystals because of the extremely low temperatures at cruising altitudes. This process involves phase changes of water, from vapor to liquid, then from liquid to solid. The tiny particles in the exhaust, like soot, act as nuclei or starting points where water molecules gather to form droplets. When the surrounding air is saturated with moisture, meaning the humidity exceeds 100%, condensation happens. The droplets then freeze into ice crystals almost instantly, creating the white streaks we see as contrails. Whether these contrails disappear quickly or last 4 hours depends on the humidity of the surrounding air. If the air is dry, the ice crystals sublimate, turning directly back into water vapor and causing the contrail to vanish. If the air is humid, the ice crystals stay and spread out, sometimes forming clouds that last for a long time. The formation of contrails is a perfect example of how changes in temperature, pressure, and humidity influence phase changes in gases. Understanding these processes helps us predict when contrails will form and how they might impact the environment. Persistent contrails can trap heat in the atmosphere, contributing to climate change, which makes studying their formation important for both science and our planet.